Hello everyone, my name is Arya Devdar and this is part 4 of NCERT Class 10 Science, Chapter 1 Chemical Reactions and Equations. So, in the last part, we discussed 10 to 11 examples of balancing equations. So, now I hope that you can balance any equation that comes your way. In this video, I am going to discuss a new topic which is types of chemical reactions. Okay, so types of chemical reactions. I hope you remember what a chemical reaction is. It is one in which not a physical, a chemical change takes place. New products are formed, and the breaking and making of bonds takes place. Okay, so there are total 7 chemical reactions we are going to study. 4 of them are the most important, and the 3 of them need to be discussed here. So the 7 are, I just copy paste it because it saves time. Yeah, okay. So these are the 7. We have combination, decomposition, displacement, double displacement, exothermic, endothermic, and precipitation. Okay, so let us start. The first one is a combination reaction. Okay, so basically, what is a combination reaction? Two or more substances, they combine to form a single product. So two or more substances or reactants, right? So in scientific terms, we call it reactants. Two or more reactants combine to form a single product. Okay? So for example, like if I give you the general formula for this, A plus B gives AB. Okay, so this is the general formula. So basically A, B and AB can be elements or compounds, whatever. But there are two or more reactants and a single product. That's the most important thing. Okay, so let's see some examples. We have seen these before, but not under the context of combination reaction. So let's see some of them. Okay, so example 2Mg plus O2 gives 2MgO plus heat plus light. Okay, so here there are two or more reactants and there is a single product. So this is a combination reaction. Example of a combination reaction. Now here you might wonder why heat and light are not products, because they cannot be called proper products. They are, you can say, byproducts here, because heat and light do not have their own chemical formula and they have not been formed by Mg and O2, right? So Mg and O2 give MgO. Okay, so you have to understand that heat and light are just some of the physical conditions which are formed after the reaction. They are not exactly products. Okay, but we write them for extra information in the chemical equation. Anyways, moving on. The second example is C plus O2 gives CO2, one of the most basic examples. Then we have N2 plus 3H2 gives 2NH3, so which is ammonia, right? And then we have a very, very important reaction, okay, as a combination reaction. It is CaO plus H2O gives CaOH twice plus heat. Okay, so here this is an important reaction because it has an important essential application. Okay, so here you have to remember some of the compounds names. CaO is calcium oxide. Okay, it is calcium oxide. Okay, it is also known as quicklime. It is also known as quicklime. Okay, H2O is obviously water, and CaOH twice is calcium hydroxide. Calcium hydroxide. Okay, and it is known as slaked lime. It is known as slaked lime. Okay, so quicklime reacts with water to give slaked lime. So you have to remember the names. ठीक है. The important application of this reaction is that, first of all, CaO is quicklime, calcium oxide. It is also known as limestone. Okay, it is also known as limestone, and this is widely used in the cement industry. Cement industry. Okay, so limestone, you know that limestone is used to make cement, right? So you have to remember the properties of CaO. And you might know that in villages, as the villagers, they cannot afford to buy paint to paint their walls. What they do, they mix calcium oxide or limestone, or what they call chuna, in water. Okay, and it releases a lot of heat. Okay, and CaOH, that is calcium hydroxide, is produced, and they use this to whitewash the walls. Okay, so you might have heard this term, whitewash the walls. That is, they apply it on the walls, and a reaction takes place between calcium hydroxide and carbon dioxide from the air to form CaCO3, which is calcium carbonate or marble. Okay, so when you apply it, they apply it one day, they wait 2-3 days, and they get a marble like finish. Okay, so they get a very shiny finish. Okay, so you might get a question like, a compound used in the cement industry when mixed with water or when dissolved in water gives a compound which is used to whitewash the walls. Write the chemical reaction and balance it, or write the chemical reaction and mention its type, or something like that. So you have to be clear with all these, properties of the reaction. Okay, so an important reaction, you can star mark it, it's very important. Anyways, moving on, next is decomposition reaction. Okay, in decomposition reaction, it is the exact opposite of a combination reaction. A single reactant, a single reactant breaks down to give two or more products. A single reactant breaks down to give two or more products. Okay, so simple enough to understand. Its general formula is AB breaks down to give A plus B. Okay, now there are three types of decomposition reactions. Combination was of only one type. Decomposition are of three types. Okay, so let's see each of them in detail. The first type is thermal decomposition reaction. Thermal decomposition. Now, thermal basically means heat. Okay, so the decomposition reaction which takes place in the presence or when heat is applied is known as a thermal decomposition reaction. Examples. So we have seen these examples in the balancing part. So I hope you remember them. I told you that they are very, very important. So this is where their application comes into play. The first one is 2PbNO3 whole bracket twice thermally decomposes to give 2PbO plus 4NO2 plus O2. Okay? So I told you that this was the one which was hard to balance, right? So you have to remember the coefficients, at least of NO2. So 4. Okay? Anyway, so this is an example of thermal decomposition. Another example is 2FeSO4 thermally decomposes to give Fe2O3 plus SO2 plus SO3. Okay, so these are the prominent examples in thermal decomposition. Anyways, moving on, next type is electrolytic decomposition. So from the name, I think it is clear that electrolytic decomposition refers to electricity. Okay, electrolytic decomposition refers to electricity. Now example, see, very simple, 2H2O decomposes by electricity. Okay, so make sure to draw the arrow big because you have to write electricity on top. Okay, decomposes by electricity to form 2H2 plus O2. Okay, so here this H2O, it is acidified water. It is acidified water. There is a reason behind that. It can come as a give reason question. The reason is that pure water does not conduct electricity. Pure water does not conduct electricity. there has to be some amount, a very tiny amount of acid added to it, or acidified or tap water, you can say. Then only it will conduct electricity, and then only it will decompose. Okay? That is why we use acidified water, because pure water, distilled water, does not conduct electricity. Simple. Okay, one more example we'll see, which is 2Al2O3 under electricity decomposes to give 4Al plus 3O2. Okay? Here, Al2O3, which is aluminium oxide, is in its molten form. Okay, it is in its molten form, and it is called alumina. So it is molten alumina. Now, why is it in its molten form? Because the aluminium and the oxygen ions, they are very closely packed in their solid state. So they need to be melted in order to, you know, attract the aluminium ions towards the cathode and the oxygen ions towards the anode. So when you cathode anode are the two forms of electricity, right? So not two forms, the experiment in which they are conducted. Okay, so that is the reason why molten alumina is used. Anyways, moving forward, the third type is, or the third one is photolytic, or it is also known as photochemical decomposition reaction. Now, what does this mean? Well, you might have heard of the term photosynthesis, right? So, in photosynthesis, photo means sunlight, right? Sunlight is necessary for photosynthesis. Everybody knows this. So, here also, photochemical is also associated with sunlight. Okay? So, the reaction requires sunlight to take place. Example, 2AgCl under sunlight, or sunlight or UV rays are also used. Sunlight basically contains UV rays. If you do it under sunlight, well and good. Or you can, apply UV rays as well. That also works. Okay? So it gives 2Ag plus Cl2. Another example, 2AgBr. So this is silver bromide. This is silver chloride. Okay? So sunlight or UV rays, whichever, to give 2Ag plus Br2. Okay? And there is an important application of both these reactions. I'll write it here. There is a very, very important application. Okay? So the application is, these reactions, they are used in black and white photography. Black and white photography. Okay? So it is a very important application. It can come in the exam. Just make sure you remember it. Okay? It is used in black and white photography. Okay, moving on. The next type of reaction we have is the displacement reaction. Okay, the displacement reaction. Now, for displacement reaction, first of all, we have to learn the reactivity series, or we have to remember the reactivity series. Now, what exactly is the reactivity series? See, the metals, each metal has its own reactivity, right? So, some metals are more reactive than the other. We say this, right? So, for that, a series has been formed in order to make sure that you remember it. Okay? So, example. Not example, I'll give you the series itself. Okay? So, the reactivity series, I'll write it over here. The reactivity series. So, see, it is K, Na, Ca, Mg, aluminium, carbon, zinc, Fe, Sn, Pb, H, Cu, Hg, Ag, and Au. ठीक है? So this is the reactivity series. How can you remember it? See, there is a mnemonic, if you know. So this is potassium, right? Make sure you remember the mnemonic by its actual name and not the symbol. Okay, it's not related by the symbol, it's by its actual name. So please stop calling me a careless zebra. Instead, try learning how copper and mercury, so and is missing, save world. ठीक है? So this is the reactivity series and this is how you can remember it. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Potassium, sodium, wait, yeah. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. Okay, after gold there is platinum, but that is not usually not used. Okay, so this is how you can remember the reactivity series. This is one of the mnemonics. I find it the easiest one. Okay, anyways, so let's see the displacement reaction here. So what exactly is the displacement reaction? In the displacement reaction, a more reactive metal displaces a less reactive metal from its salt solution. A more reactive metal displaces a less reactive metal from its salt solution. Okay, so let's see some examples here. Or first, the general form is A plus BC gives AB plus C. Okay, simple. So A and B are metals. I'm sorry, A and C are metals, and B is the salt solution of C. Okay, so and A is more reactive than C, hence A displaces C. Okay, okay. Now examples here. The most common example is FeSO4 plus CuSO4 gives FeSO. Oh, I'm so sorry. I'm so sorry. Fe plus CuSO4 gives FeSO4 plus Cu. Okay, most common example. Now here Fe is iron and it is in its solid state. CuSO4 is aqueous. FeSO4 is aqueous and Cu is solid. ठीक है? Here CuSO4 is blue in color. I'm so sorry. Yeah. CuSO4 is blue in color and FeSO4 is green in color. The color basically changes and you see the gradual change in the color. So as you can see in the reactivity series, Fe is above Cu, right? So this reaction is valid. Okay. Now, second example, Na plus PbSO4 gives Na2SO4 plus Pb. Here too. Yeah. So here as well you can see Na is more reactive than Pb and hence this reaction is also valid. Okay. Now I'll give you one more. Al plus K2SO4 gives Al2SO4 thrice plus K. Is this reaction valid? Now see, Al is here and K is here. So can Al displace K from its salt solution? No, because Al is less reactive than K, potassium basically. Okay, so this reaction is not valid, or basically you can write here no reaction takes place. Okay, simple. So this is the way displacement reaction works. Now moving on to double displacement reaction. Okay, here in double displacement reaction, the mutual exchange of ions takes place. the mutual exchange of ions takes place. What does this mean? See, the general formula is A plus B minus plus C plus D minus gives A plus D minus plus plus C plus D minus. This is the general formula. Okay. Now, what does this tell us? Well, basically here it is a positive ion. Sorry. Yeah. Here it is a positive ion, negative, positive, negative. Okay. Now this positive, it reacts, it goes and rearranges itself with this negative, and this negative, it rearranges itself with this positive. So mutual exchange. Mutual means all ions exchange each other. So it becomes AD plus BC. So AB plus CD gives AD plus BC. Simple. Okay. Now let's see some examples here. Just rubbing this out. Okay, yeah. So let's see some examples here. Example. BaCl2 plus K2SO4 gives BaSO4 plus KCl. See here, Ba plus Cl minus K plus SO4 minus Ba plus SO4 minus K plus. So this went with this went with this. Okay, simple, not very difficult. Now here the products are important because this is aqueous, this is a precipitate, and this is aqueous. Okay. In almost all the double displacement reactions, precipitate is formed. All the double displacement reactions, precipitate is formed. Here, barium precipitate, it is a white PPT. Okay. Two more examples. We have Na2SO4 plus BaCl2 gives BaSO4 plus NaCl. Na plus SO4 minus, Ba plus Cl minus, Ba plus SO4 minus, Na plus Cl minus. This went with this went with this. Okay. This is how you write it as well. Okay. Here again, barium this is a white precipitate. All others are aqueous. Aqueous, precipitate, aqueous. Okay. And this is also white color. Now the last example is NaOH plus HCl gives NaCl plus H2. Aqueous, precipitate, and this is liquid because H2O itself is water. It cannot be aqueous. H2O cannot be dissolved in water because it is water. Okay, so liquid. Precipitate, this is colorless because it dissolves in water. NaCl is basically sodium chloride, your table salt. Na plus OH minus H plus Cl minus, Na plus Cl minus H plus O2 minus. Okay? This is also a neutralization reaction. We'll see more about that in acid bases. Okay, but still, this is also a neutralization reaction. Now the other three which are remaining, I'll talk about them in my next video. So for now, this is all. We talked about 4 reactions: combination, decomposition, displacement, and double displacement. So that's it for now. Thank you so much.